we shall discuss about the mineral content of coals. So in addition to the purely organic substance, both the macerates and microlithic type of coals, they invariably contain smaller or larger amounts of inorganic components, which is referred to as the mineral matter. So if you go by the definition of mineral, it is an inorganic substance. And in the coal, we have the maceral and microlithotypes. Like I have told you about the three different types of maceral groups, and then of course the microlithotypes as urane, clarine, vitrine, and fusane. So they are organic compounds, organic substances, but all of them invariably have this mineral matter. And from where this mineral matter is derived, see, once the coaliferous material, the material which is forming the coal, it gets deposited, along with it large amount of sediments, they get incorporated, and sediments are nothing but the mineral matter only. So the mineral matter is classified into three groups. First one is the inorganic matter from original plants. So several plants are there which give rise to some of the inorganic material. Then second one is inorganic organic complexes and minerals formed during the first stage of coalification process, which were introduced by water or wind into the coal deposits as they were forming. So we have called them syngenetic. Syngenetic means the mineral matter is being formed along with the coal. So in easy words, forms along with the coal. So if you try to guess its age, the age of mineral matter and age of the coal will be the same. So they are normally the types of coal which are formed during the first stage of coalification, or while the peat was being formed. Along with the peat, these were brought in by agents of erosion. Now the third is the mineral deposited during the second phase of coalification process. Means, let us say the coal has formed, coal has consolidated. By consolidation, there are some development of cracks, fissures, cleavages, cavities. In those cavities, the mineral gets deposited. They are called as epigenetic. Epigenetic means formed later. So we have two types of mineral matter, the syngenetic and epigenetic, and of course one is the inorganic material from the original plants. So in simple common words, this mineral matter, it is defined as the non-combustible fraction of coal. Means it cannot be burnt. And so after the coal is burnt, in which form the mineral matter is left behind? It is left behind in the form of ash. So higher the ash content of the coal will imply that the mineral matter was considerably high. So as this we saw that they are either syngenetic or epigenetic. And then the mineral material, so I'll write mineral matter can be either orthogenic or it may be detrital. So if I say the word orthogenic, means it got generated at its original place, or detrital means it is transported. So the most common detrital minerals in in coal, they are quartz, carbonates, then iron bearing minerals, and clay minerals. These are the most common detrital minerals found in the coal. While the orthogenic minerals, they are calcite, anchorite, then pyrite, very commonly found. Then you have siderite and free silica. So these are the uh, orthogenic minerals which are found associated with the coal. I hope you are getting till this. Now, calcite, we all know this is calcium carbonate. What is anchorite? Anchorite is a calcium, iron, magnesium, manganese carbonate mineral. Okay, so if you try to remember the formula of anchorite, it is a calcium, then Fe, Mg, Mn, CO3 whole twice. Okay, it is a type of orthogenic mineral of the coal. Now, along with all these, sulfur is present in almost all coals. Present in almost all type of coals. And in which form? It is usually present in the organic fraction. Okay, but so it is found in all coals as organic fraction. But if it is present in the form of mineral, then it is present as pyrite. Okay. Now, this pyrite may be present as either primary detrital mineral or secondary precipitated mineral. So, pyrite may be primary detrital or it may be secondary precipitated mineral. So, you can now understand that how the different types of uh, mineral matter they are found in the coal seams. Okay. Now, the clay minerals, the clay minerals, they are the most important mineral group in coal because they make up around 60 to 80% of the total mineral matter. So the clay minerals, they make up around 60 to 80% of the total mineral matter. And clay can be both. It can be detrital as well as orthogenic. So the commonly found detrital and orthogenic clay minerals in coal, they may be kaolinite or illite or sericite. These are the commonly found clay minerals in the coal. Okay. So which type of clay mineral will be found depends on the environment of the swamp. Okay. So if there is fresh water swamp with low pH, means acidic, then here there will be in situ alteration of smectite. You should remember these names of the clay minerals: illite and kaolinite. If it is a marine influence coal, then you will find illite as dominant clay mineral. If it is a non-marine coal, in this type of environment, you will find kaolinite as the dominant type of coal. Now, if the coals are subjected to higher pressure and temperature, okay, coal, it is subjected to higher pressure and temperature, then here the primary clays, they are altered to chlorite. So in coal subjected to higher pressure and temperature, the commonly found clay mineral is chlorite, and this chlorite is derived from alteration of primary clays. Okay, so these clay minerals, we are all aware that the clay particles are the finest sedimentary size. So the clay minerals, they occur as finely dispersed inclusion in the maceral lithotype. Okay, so how are these clay minerals found in the coal? They occur as finely finely dispersed inclusion in maceral lithotypes. Maceral lithotypes. There is one more way in which the clay occurs in the coals. It occurs as tungsten. So how is tungsten defined? Tungsten is a hard, compact sedimentary rock which is composed mainly of kaolinite or other clay minerals. Okay, so it is a hard, compact rock composed mostly of kaolinite or other clay minerals. Now, the clays are often cemented by iron oxide minerals, carbonaceous matter, or chloride. Here, the cementing material is iron oxide, carbonaceous matter, or chloride. What are these? These are all cementing material in tungsten. They form from volcanic ash deposited in swamps, and normally they occur as distinctive thin and lateral layers in coal seam throughout the world. Okay, so the tungsten, it is a commonly found material of clay minerals all across the globe. Okay, now on being analyzed for the clay content, okay, so if the microlithotypes of coal, microlithotypes of coal, if they have less than 20% by volume, 20% by volume of clay minerals, then they are called as contaminated by clay. Contaminated by clay. If the clay minerals, if the clay minerals, they range from 20 to 60% by volume, then we use the word carbargillite. Carbarg or carb argillite. Okay, then if the clay minerals, they are more than 60% by volume, then now we use the term argillaceous shale, not coal. So this is argillaceous shale, not coal, then we can say that this argillaceous shale is having some amount of organic matter. The clay minerals, carbargillite and argillaceous shales, all three, okay, all these, they swell in water. We all know that the clays, they have the property of swelling in water. That is because of the silicate structure of the clays. And this swelling, it almost always leads to substantial reduction in strength and disintegration of the coal. So if this clay material is present in large amount in the coals and they are subjected to water, that could be the atmospheric water, meteoric water or groundwater, then these such clays are bound to develop large amount of cleats, fractures, cavities. I will also tell you about the structures found in coal seams, and in that we'll see what are the different types of coal structures. But if clay mineral is present, because of its swelling, it causes reduction in the strength of the coal and disintegration of the coals. Now we come to the carbonate minerals. Other than coal, this is the second most frequent mineral in coal. They form in both the stages of qualification process. So in the first stage as well as the second stage. The syngenetic type of carbonates which are commonly found in the coals, they are siderite, it is iron bearing carbonate, and dolomite. So if a question is asked which is the syngenetic type of carbonate mineral found in coal, then answer will be siderites and dolomite. The dolomite, it occurs in coal seam influenced by marine invasions as well. So dolomite is also found in coals which have marine influence. The epigenetic carbonate minerals found in coal, they are calcite uh, and anchorite. Calcite and anchorite. And how are they deposited? This calcite and anchorite, they are deposited as epigenetic mineral in cracks and fissures or the cavities of the coal. In which stage? Second stage of qualification. So if this clay mineral, if it is present 20 to 60% by volume in the coal, then this is called as carb anchorite. We use the word carb anchorite for such coals. Okay. Next is sulfide minerals. Sulfide minerals, which are found most commonly in coals, they are pyrite and marcasite. They both are polymorphs of each other and both have the chemical composition FeS2, where pyrite, it belongs to the cubic system, while marcasite, it belongs to orthorhombic system. Apart from pyrite and marcasite, the coal seams, they are also found to contain small amounts of sphalerite. Sphalerite, which is, I hope you all know that it is ZnS, zinc sulfide, sphalerite. Then, other than sphalerite, galena, lead sulfide, and then chalcopyrite. So, apart from pyrite and marcasite, these are the other sulfide minerals found in smaller quantities. Now, excessive pyrite means which is having a high sulfur content is not desirable for the coking coals. Okay. And coal deposits in the paralic basins, they are richer in pyrite than those deposited in limnic basins. I had told you in the very beginning about the paralic coals and the limnic coals. So, pyrite is higher in paralic coals, while it is lower in limnic coals. Now, you can, if you understand the difference between the paralic coals and limnic coals, you can easily find out why the content of pyrite is higher in paralic coals. So try to find out the answer to this question, why pyrite is found in higher amount in paralic coals. And in among the paralic coals also, the seams which have been influenced by marine transgression. So in paralic coals, the coal seams influenced by marine transgression, they have higher pyrite content. Higher pyrite content. And then the uh, other types of minerals found in coal, they are oxides and hydroxides. So among oxides, quartz is a very commonly found mineral, SiO2. So intergrowths of coal and quartz, they are found as the product of first stage of coalification. Now there may be the presence of clastic quartz, means the detrital quartz which is transported, and precipitated silica. So how to understand the difference between the clastic quartz and the precipitated quartz? You should try to find out the grain shape and size. The clastic quartz will be rounded and sand sized, while the precipitated quartz will be finely crystalline. Okay. So you may have clastic quartz, you may have precipitated quartz. And how to differentiate? The clastic quartz is rounded and sand sized, while the precipitated quartz is finely crystalline. Other than quartz, some rare oxides and hydroxides which are found. So rare oxides and hydroxide minerals, they are hematite, limonite, goethite, etc. So this is all about the mineral matter present in the coal. for what is required for you. So you have to understand over here that mineral matter is an indigenous content of the coal seam. There cannot be any coal seam which will not have mineral content in it, just because it is being deposited in sedimentary setting. And once you are talking about the sedimentary settings, then we are definitely going to look at the weathering and erosion of the associated rock types. The tectonic movement of the plates has also given rise to large amount of the mineral matter. Other than that, if the vegetal material or dead plant material gets deposited at its place in situ, then it is bound to have a lesser mineral content than the coals which is formed by the transported plant material. Say if a tree falls at its place and gets deposited there, then the mineral matter associated with it will definitely be lesser. But if the tree is getting drifted, transported to some other location, then definitely that coal seam will be having a higher mineral content.